Hello and welcome. In this video, we're going to talk about characteristics of quadratic functions. We're going to focus on symmetry, whether a function opens upward or downward, the max or min value, where it's increasing or decreasing. And we're going to focus specifically on two different forms of the quadratic. We're going to focus on vertex form, how to use a function that's in vertex form and identify those characteristics, how to graph it, and then standard form. So let's go ahead and jump right in. So let's start with talking about the shape and the specific characteristics that help us graph and use a quadratic function. So one of the most important things about a quadratic function that helps us graph it and helps us use it and is really unique to it is that it has an axis of symmetry. So this red line over here, this vertical line, x equals h, that is the axis of symmetry. So an axis of symmetry is a line that divides the parabola into mirror images so that you could fold it along this line and everything on the left would line up with everything on the right. So that's going to be true for every quadratic function. Every quadratic function has an axis of symmetry, and that axis of symmetry always passes through the vertex. So that axis of symmetry is always the line x equals whatever the x value of the vertex is, and we've been referring to that as h. So that horizontal translation. So axis of symmetry divides the quadratic in half. You can fold along that line and everything matches up, and that is the line x equals h, the x value of the vertex. And speaking of that vertex, the vertex, which is either the highest or lowest point on the parabola, has a specific value that is either the highest or lowest value in the quadratic. And we talked about this specifically, we looked at that high and low value when we talked about the idea of range in chapter 1. So the y value is either the maximum value or the minimum value. So if you're asked for the max or the min of a quadratic function, you're not being asked about the point, you're being asked about what is the highest it ever goes, that's the y value, or what is the lowest it ever goes, that's the y value of the vertex. We can tell from a function if the quadratic or the parabola is going to open upward or open downward by looking at A. And no matter which form, because we are eventually going to learn 3 different forms of quadratic functions, no matter what form it's in, A is always going to be that determining factor that tells you if it's opening upward or downward. So the leading coefficient, if it is greater than 0, if it is positive, it's going to open upward. If it is less than 0, if it's negative, that would mean there's a reflection across the x-axis. That means that parabola is going to open downward. So some of these are review, axis of symmetry, max or min value, whether it's opening upward or downward, but this last characteristic should be new to you. We can talk about the intervals on which a quadratic is increasing or decreasing by looking at the x value of the vertex. So what I'm going to do is I'm actually just going to draw a quadratic here. And what I want you to see is if you put your finger along the left-hand side and we work left to right, right now I'm going down, 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 down until I hit the vertex. And then I start going up, 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 up. So we could say that our quadratic, and I'm going to call the vertex HK, we could say that in this case, it is decreasing on the interval from negative infinity to h, because everywhere to the left, we're going down. Once we get to that vertex, we start increasing and going up. So if I traced from the vertex to the right, I'm going up, up, up. So we could say that it's increasing on the interval from h to infinity, because we're talking about the x values. It's decreasing until it gets to the vertex. It's increasing until it gets to infinity. Now, the opposite of that would be true if we had a parabola that opened downward. This is still the point HK. We would know that it opened downward because we would have an a value that was less than 0. There'd be a reflection across the x-axis. But if I trace this quadratic from left to right, to the left of the vertex, up to the vertex, I'm going up. So I am increasing along this line, and then I am decreasing along this part of the function. So I want you to see that right now. I'm increasing and then I'm going down and decreasing. So that's going to change this interval of increasing and decreasing. So now I'm increasing from negative infinity to the x value of the vertex and decreasing from the x value of the vertex to infinity as x goes on forever and ever to the right. So this is new. I really want you to pay special attention to this as we're working through. We're going to think about where it's increasing and decreasing. So let's focus specifically on vertex form, since what we just pointed out is that the vertex helps us identify the axis of symmetry. It helps us identify the max or min value of the parabola. And if we know the vertex, we can find the intervals over which we are increasing and decreasing. So let's focus on vertex form first, which we learned a little bit about in the last video. So in the last video, we talked about vertex form, and vertex form is f of x, or y, equals a times the quantity x minus h squared plus k. And we actually talked about how the vertex is h comma k, so the opposite of what you see inside, that horizontal translation, comma k. When a quadratic is already in vertex form, you can right away identify that vertex, which means you can also right away identify the axis of symmetry, which is going to be the x equals the x value of the vertex. So let's apply that to these two functions which are in vertex form. We're going to find the axis of symmetry, the vertex, and we're going to talk about whether they open upward or downwards. And I'm actually going to add a little bit about a couple of other things in here as well. So let's start by identifying the vertex. The vertex is the horizontal translation, so 2 to the left, the opposite of what we see inside, comma, the vertical translation, -4. That means that the axis of symmetry is the line x equals -2 because it's the x value of the vertex. Now, if we want to talk about whether this quadratic opens upward or downward, we only care about this leading coefficient, which is positive, so this parabola is going to open upward. Now, these are the only three things that we were asked to do on this problem, but I want to take it a little bit further. If this quadratic, or this parabola, opens upward, is there a max or is there a min? I want you to ask yourself that question. Is there a highest point or a lowest point? Well, these arrows are telling me there's not a highest point. It goes forever up, which means there is a minimum. And the minimum is the y value of the vertex, which is -4. So the minimum of this function is -4. The smallest the output of the function ever is -4. And then if we wanted to extend this a little further to talk about increasing and decreasing, we're going down and then we're going up. So we could say that this is decreasing from -infinity to the x value of the vertex, which is -2. And increasing from the x value of the vertex up to infinity. So I know those last parts weren't required, but I really just wanted to take a minute to pause and identify those key characteristics. Number 2, I'm going to just slightly rewrite, because right now it doesn't really look like it's in vertex form, but if I just write it like this, I think you can see that it is. So if there's no parentheses, that just means that there is no horizontal translation happening, which means the x value of the vertex is 0. So the vertex here is going to be 0, -7. 0 coming from here, -7 coming from here, which means the axis of symmetry is x equals 0 because that's the x value of the vertex. In front, we have a 2, which means this quadratic is going to open upward. And I want you to see if you can identify, and this is going to be really similar to the last one, if there's a max or a min and the interval on which this is increasing or decreasing. So go ahead and pause the video and try and do that on your own. All right, just like on number 1, there's going to be a minimum since this quadratic is opening upward, and that minimum is the y value of the vertex, -7. It is decreasing from -infinity to the x value of the vertex, which is 0. It's going down, and then it's going up after the vertex, so it's increasing from 0 up to infinity. So now let's talk about how identifying these characteristics in vertex form actually makes it easier for us to graph. All right, what I want you to do is I want you to identify the axis of symmetry, the vertex, and whether or not each of these quadratics opens upward and downward. So go ahead and pause the video and try that on your own. All right, so first things first, the vertex on number 3 is the opposite of what's inside with x and the vertical translation. So that's -3, 4. Then the axis of symmetry is the line x equals -3. You can't say the axis of symmetry is -3. It has to be the line x equals -3. And this parabola is opening downward. Now there's also a vertical stretch that's happening that's going to play a part when we are graphing. But what I really want to focus on first here is let's go ahead, plot the vertex and the axis of symmetry. So -3, 4, 1, 2, 3, 4. I'm actually going to go ahead and draw a little dotted line here indicating that this is the axis of symmetry. This is going to help us because anytime we plot a point on one side of that axis of symmetry, we can reflect it over to the other side. And we know that our quadratic is going to open down. So really what we need, we just need 2 points, one on the left side or 2 on the left side that we can reflect over to the right side or vice versa. So just like I did in the last video, I'm going to make a table. I'm going to put my vertex in the middle of the table. And I'm going to pick numbers that are relatively easy to plug in. So my first instinct would be to plug in 0, but if I plug in 0, I'm going to get a really big number, I think, and that's going to be hard to fit on my graph. So let's just look at what happens if we plug in -4, -5, -2, -1. So because of symmetry, whatever I plug in, whether it's -4 or -2, the output, the f of x value, is going to be the same. So if I plug in -4 on the inside of parentheses, inside here, I'm going to get -1 squared, which is 1, times -2. So -2 plus 4 is going to be +2. So I have that value on both sides, both -4, 2, -4, 2, and -2, 2. If I plug in -1, if I plug that in here, -1 plus 3 is 2, +2, squared is 4, times 2 is -8, plus 4 is -4. So that's going to be the value for both of these points, and I'm going to go ahead and plot those 2 points. Now I have 5 points graphed, so I'm going to go ahead and connect to make my quadratic. Okay, on number 2, hopefully, or number 4, hopefully you already identified that the vertex is -4, -2, and that the axis of symmetry is the line x equals -4. And since this 1/2 in front is positive, this opens upward. Those are just good things to check, especially which direction it's opening is really going to help you make sure that your graph makes sense after you're plugging in those values. So here's my vertex. I'm going to go ahead and plot my axis of symmetry as a dotted line so I can use that to reflect. And then I'm going to construct a table. Now make sure that you know the expectations of your particular teacher, which may or may not be me, when you are graphing this. For me, I want all of the important information labeled off to the side. And it says specifically, label the vertex and axis of symmetry. It doesn't say you have to label whether it opens upward or downward, but I just want you to see this is all labeled here. If you have a different teacher, you might be asked to label things on the graph. I want to see that your axis of symmetry as a dotted line. I want to see your vertex plotted as a point. Some people might want those to be labeled on the graph as well. So just pay attention to what is expected of you in the class that you're in. Okay, I'm going to go ahead and plug in some even numbers since I noticed that I'm going to have to multiply something by 1/2. So I'm going to look at -6 and -8 and -2 and 0. And I would much rather, if I have to plug in either -6 or -2, I'd rather plug in -2. If I plug -2 in here, I'm going to get 2 squared is 4. Half of 4 is 2 minus 2 is 0. So both -6 and -2 are going to cross at 0. And then I would much rather plug in 0 than -8. If I plug in 0, I get 4 squared is 16. Half of 16 is 8. 8 minus 2 is 6. And then I'm going to go ahead and plot those points and connect them. And I'm going to make sure that my graph has arrows on the ends of it. If this question asked me about increasing and decreasing, I can see on number 3 that I'm increasing to the left and decreasing to the right, and on number 4 that I'm decreasing and then increasing. We aren't asked about that specifically here, so I'll focus on that on a couple more examples a little later in this video. So now that we have a pretty solid foundation of how to identify characteristics from vertex form and how to use that to graph, let's focus on standard form a little bit. So standard form is the form that you most often spend time with in Algebra 1 when you're solving quadratics using all of the different strategies that we use. Standard form is ax squared plus bx plus c, or f of x equals that, where a is not 0 because then we wouldn't have a quadratic. We wouldn't have a term that's being squared. So some of the properties that we have learned in previous classes is that we can find the axis of symmetry using sort of a formula, x equals the opposite of b over 2 times a, which means to find the vertex, we know that the axis of symmetry is the x value of the vertex. We can just plug that into the function to find the y value of the vertex. We also know from all types of functions that we can find the y-intercept by just plugging in 0, and that usually is a pretty easy point to find when we are graphing. What we just talked about before when we were talking about vertex form is this a value and how that helps us identify if the quadratic is going to open upward or downward, and that is still true. This a means exactly the same thing in standard form as it does in vertex form. So let's practice using this approach to identify the axis of symmetry, the vertex, and let's go ahead and find the y-intercept as well. So axis of symmetry, we need to take the opposite of b over 2 times a. Well, a in this case is 1/2, b is 6, and c is -2. So if we take the opposite of b, that's going to be -6 over 2 times a, and a is 1/2. Now, don't get scared with the fraction and the fraction. The denominator is just half of 2, which is 1. So the axis of symmetry is just x equals -6, which means we also just found the x value of the vertex. How do we find the y value of vertex? We plug in -6. So g of -6 is going to be 1/2. -6 squared is 36, plus 6 times -6, minus 2. Half of 36 is 18, minus 36 minus 2. This is going to give us -20. Glad we don't have to graph this one. That would be hard to fit. So axis of symmetry, x equals -6. Vertex is the x equals -6 is the x value, and then we plug that in to find the y value. And then to find the y-intercept, we're just going to plug in 0. If I plug in 0, I get -2. This is our y-intercept. Now, we aren't asked this, but this opens upward since a is positive, which means we could talk about increasing and decreasing. It's going to decrease from -infinity to -6, and then it's going to increase from -6 to infinity, right? Because we're looking at the x value of the vertex. All right, I'm going to encourage you to pause the video and work through number 6, finding the axis of symmetry, the vertex, and the y-intercept all on your own, and then unpause the video and see how you did. So the axis of symmetry here is going to be 8 over 2 times 4, which is going to be x equals 1. So that's the x value of the vertex. To find the y value of the vertex, we're going to plug in 1. When we plug in 1, we're going to get -3. -3. So here's our axis of symmetry, here's our vertex, and then the y-intercept is just going to be 0, c. If I plug in 0, I get 1. This is the y-intercept. And if I asked you about opening up or down, you would tell me that this opens upward, which would mean if we were asked about max or min, in this case we would have a minimum value, and that minimum value would be the y value of the vertex, which is -3. All right, let's extend this to graphing. So in the same way, we're going to start by identifying that key information, plotting it, and then making a table to fill in the gaps that we have to create the rest of the shape of our quadratic. All right, so what I'm going to encourage you to do before we talk about how to graph is exactly what we just did. Find the axis of symmetry, find the vertex, and find the y-intercept. So go ahead and pause the video and do that for both number 7 and number 8. So hopefully you had time to do that. The opposite of -6 is 6 over 2 times 3. The axis of symmetry is going to be x equals 1. The vertex is going to be 1, and then what I get if I plug in 1. So if I plug in 1, I'm going to get 3 minus 6 plus 1. So this is going to be negative 2. And then my y-intercept, if I plug 0 in, I get 1. The y-intercept is 0, comma, c. And here's c, right? A is 3, b is negative 6, c is 1. Similarly, on number 8, I'm going to identify a, b, and c. I'm going to find the axis of symmetry first. X equals the opposite of negative 4 over 2 times 1/2. This is going to be 4 over half of 2 is 1. So x equals 4 is going to be the x value of my vertex and my axis of symmetry. And then I'm going to plug in 4 to figure out what the y value is. So half of 4 squared is 16, minus 4 times 4 is 16 minus 2. If I simplify this, I'm going to get 8 minus 16 minus 2, which is going to be negative 10. And my y-intercept on this function is going to be 0. If I plug in 0, I get negative 2. So just like we did with vertex form, after we find this information, after we find the axis of symmetry, the vertex, we're going to go ahead and graph it. So I'm going to graph the vertex, 1, negative 2. I'm going to graph my axis of symmetry, my dotted line here. And then we can make a table. One thing I want you to know is that we already found a point that's on our graph. So I can plot the point 0, 1. I'm going to plot that in blue. And then because parabolas are symmetric, I can reflect that point over to the other side. So now the only thing I really need to do is find one more point that I can reflect over. So I can set this up in a table. It's also okay for you to just show the work to find one more point. My vertex was 1, negative 2, so I'm looking at 0, which I already found out was 1, which means 2 is 1. And if I plug in negative 1 or I plug in 3, I should get the same value. So if I plug in negative 1, f of negative 1, that's going to be 3 times 1, negative 1 squared, so 3, minus 6 times negative 1 is going to be positive 6 plus 1. This is going to be 10. And I can reflect that point. So I'm going to plot the point negative 1, 10, and I'm going to reflect that over to the other side. And now I have 5 points, so I can connect my graph. And I can make sure that my graph has arrows. Now we're going to do the same thing on number 8. So I'm going to start by plotting my vertex, 4, negative 10. And I'm going to plot or graph my dotted axis of symmetry. I'm going to, since I found the y-intercept, which is 0, negative 2, I'm going to graph that. And I can reflect that on the other side. And now I really just need one more point. So if you don't want to make the table, just show the work for one more point. What's an easy number to plug in here? I'm going to plug in 2. So I'm going to find f of 2. 1/2 times 2 squared minus 4 times 2 minus 2. And I'm just picking 2 because I can tell that it's going to be in between here somewhere, which means I can reflect it over here. So 4, half of 4 is 2. 4 times 2 is 8. So this is going to end up being negative 8. So I can plot the point to negative 8. So 2, negative 8 is going to be here, and I can reflect that over to the other side. And now I have enough to connect and make my graph. Since we have these graphs, let's talk about increasing and decreasing. So I'm going to erase some of this work on the bottom so we can look at our graphs and talk about where our parabolas are increasing and decreasing. There we go. Now we have some room. So if we look at number 7, the first question I want to ask you is the vertex the maximum or the minimum? Is it the highest point or the lowest point? And hopefully you can recognize that it's the lowest point. And if I ask you what the value is, what is the minimum value, what I'm asking you is what is the lowest this function ever goes? And that's going to be the y value of the vertex. That's going to be negative 2. Now if I asked you what's happening to the left of my vertex, hopefully you could tell me that we are going down. If I start on the left and I trace towards the vertex, I'm going down. What that means is my function is decreasing from negative infinity, so as far as we can go to the left, until I get to the x value of my vertex, which is 1. Once it gets to 1, it starts increasing. It starts going up. And this is always going to happen. Half of our parabola is going to be increasing and half of it's going to be decreasing. So from x equals 1 up forever, it's going to be increasing from 1 to infinity. Now, different people have opinions on whether this should be a square bracket or parentheses. For right now, we're going to leave it as parentheses because it's hard to say at that value, can it be both increasing or decreasing? And we're going to leave that for future classes to discuss with you. For me, I'm going to accept it both as parentheses and as square bracket. So similarly for number 8, if I asked you, is there a maximum or minimum value? It goes up forever, so there's not a maximum value, but there is a minimum value. The lowest this graph ever goes is -10. If I asked you about increasing and decreasing, I am getting smaller, so I am decreasing from -infinity until I get here, and x right here is 4. And I'm increasing from that point up forever, so I'm increasing from 4 up to infinity. So it seems like an awful lot of work if something is in standard form to have to figure out how do I find the axis of symmetry in the vertex, and how do I use my graph to tell if something is increasing or decreasing or what the maximum or minimum value is. So what I want to talk through in our last 2 examples in this section is, could we do some of these things without actually having the graph? So that's what we're going to look at in our last 2 examples. So here we have 2 problems, and we're being asked to find the max or min value, the domain, the range, and where this is increasing and decreasing. So really, if I know my vertex, and if I know whether this parabola is going to open upward or downward, I will have enough information to do all of those things. So the first thing that I notice here is that my A value is 1/2. So A is positive. That means this graph is going to open upward, which means I have a minimum, not a maximum, because I have the vertex is going to be the lowest point on my graph. I also know from chapter 1 that the domain to a quadratic function, unless it's specifically limited, like if we had a word problem, is all real numbers, which I'm going to write as -infinity to infinity. In order to answer any other questions, we really need to find the vertex. So I'm going to encourage you to pause the video, find your axis of symmetry and plug it in to find your vertex, and then unpause the video and see how you did. So finding the axis of symmetry, we get that x equals 2. Plugging in x equals 2, we get that the vertex is the point 2, -3. What that means is our minimum value is the y value of that vertex, which is -3. Our range, looking at the fact that we said it opens upward, our range is going to go from that lowest value, -3, up to infinity, because the lowest value and then up forever. Also looking at that shape now, if we want to talk about where it's increasing or decreasing, I'm starting by decreasing. So from -infinity until the x value of our vertex, which is 2, we are decreasing. And from the x value of our vertex over to infinity, so 2 to infinity, we are increasing. Now, I much prefer looking at this than to actually having to walk through and graph everything. So if you're not being asked to graph, you can still find all of this key information. All right, I'm going to encourage you to pause the video and work through number 10 completely on your own, and then unpause the video and see how you did. So here we go. This quadratic is going to open downward, so we have a maximum. After we find the vertex, that y value is going to be our maximum, which is 2. The domain is still -infinity to infinity. Since this is opening downward, our range is going to be -infinity up to that y value of the vertex, 2 being the highest this graph ever goes. We are increasing if I start from the left and work towards the vertex. So we're increasing from -infinity to the x value of the vertex, which is also 2, which means we're decreasing from the x value of the vertex forever after that. So key things that we focused on in this video, we talked about both vertex form and standard form, how to identify the vertex and axis of symmetry, and how to use those properties to graph. Then we talked about key characteristics of quadratics, like the max or min value, the domain, the range, and increasing and decreasing. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening. Value would be